So how familiar is everyone with the current build system?
I have some knowledge, so I'm not sure about these. Make it as neat to building itself, I guess.
All right. Well, maybe. Go ahead.
Yes, go ahead.
I was saying maybe I could just kind of talk. I mean, I don't have a ton of slides like kind of going through the history, but I can sort of talk to it. And if we need to like put a camera against the whiteboard or something, we can do that. But I guess the high level point here is that. Yeah, I'm recording. Yeah. Okay. So the high level point is that when we started the project, we built everything with Maven, which is kind of like common, more or less, was the de facto standard for doing Java-based builds. And so we had a standard hierarchical Maven project. So the way Maven kind of works is you have a relationship between modules. So each module is defined by a POM, and then the modules typically have artifacts that get generated by various build phases and plugins. And so what effectively happens is you have an ONOS root POM that was defined, which has some base dependencies and also some build configuration. And then you have all of its submodules, which are defined like that more or less mirror the structure of the code tree. So you had API, or sorry, core and apps and providers, protocols, drivers, etc. And so one of the challenges that we were having here is that there's not really well, Maven uses timestamps to determine whether a module needs to be rebuilt. And it also needs to be aware of all of the files and targets that you're generating, which some plugins don't make available. And so in order to do incremental rebuilds in Maven, you have to have pretty specialized or pretty good understanding of like what had changed. And there were a few efforts to try to build some tooling around incremental or selective rebuilds, but they weren't very reliable because you could check out like a new branch and you'd have to know exactly what parts of the code tree needed to be rebuilt and how they were dependent on one another, so that you could build the jars and package them in a sensible way. The other thing is, if you forgot to rebuild something, you could be linked against the old version of stuff. Anyway, the point here is that there are definitely people that have gone through the process of figuring out how to do selective rebuilds in Maven, but when you're dealing with multiple branches and switching between those branches, it can get sort of complicated. And at the same time as the project was growing, we had sort of bigger and more modules, up to like 180 or 200 modules. And the way Maven works is that it spins up, an instance of each of the plugins for each of the modules. And so there's a lot of overhead. Even if a plugin wasn't running, it would still spin up. So the point is that we were Maven based. We had POMs throughout the source tree. We started looking at ways we could improve both the reliability of the build, producing deterministic results, and also improving the time that a developer would need. It got to a point near when we decided to make a switch that it would take like 20 minutes to do a full rebuild. So there were a couple of high productivity developers that kind of knew what to do and could get that process down to like under or around a couple minutes. But for most people who were developing, it was just 20 minutes every time they wanted to make a simple change, which is kind of crazy. So what we did at the time was we were looking at Gradle, looking at the Blaze family of projects. Buck was the most mature and sort of was the closest to what we needed at the time. So we spent some time basically porting the Maven-based process over to Book. Now, unfortunately, we never got 100% there in terms of like being able to build all the modules because basically we got to the point where 99 or whatever 95% of the code was built using Buck, but we were sort of hoping that people would kind of fill in the gaps. And I think we've also kind of identified a few other areas for improvement. But we can get more into that, I guess, tomorrow. But yeah, the high level story here is that we migrated to Buck, which is a build system where instead of being sort of Maven style in terms of its architecture, instead has you explicitly define your dependencies. So you explicitly define all the inputs to your build rule, whether that's build rule parameters, source files, etc. And then there is a build step that produces an artifact as an output. And that artifact, because you can hash on the inputs, you can determine whether or not you've already done the work. It's resilient to source code changes as long as all the inputs are actually being tracked by the build rule, which is the goal. And
it takes the signature of the API so that it knows what to compare if the base API is changed, so that it doesn't compare everything.
Right. Yeah. So that's another for the Java source. For the Java sources, it also looks at API signature. The other thing is because the rules are deterministic, and it knows like the dependency graph between. Well, so Maven to some extent builds a dependency graph as well, and Maven to some extent can permit some degree of parallelization. But Buck is sort of better parallelized, so it's better suited to taking advantage of multiple cores on a developer's machine. And it's also, it's more resilient for situations where you want to switch between branches or just incrementally rebuild without necessarily needing domain knowledge of the dependencies between modules. So,
but Buck doesn't take care of the transitive dependencies, not like Maven.
Doesn't take care of what?
Suppose if A is dependent on B, and I know A, I can put B as my dependency. But what if B depends on C and C depends on D? In Maven, I don't have to explicitly specify it. I just have to tell that I depend on B, and then Maven will go ahead and find the dependencies for B, C, and D. Whereas in Buck, I need to put all the way from A to D.
Well, you only have to name the dependence. Like you can have transitive dependencies that don't need to be named. When it builds the DAG, knows the directed acyclic graph of dependencies. Knows. So I think what you're talking about is like, for example, like the ONOS API module, pulls in and exposes a few other dependencies, like other various Guava, Jersey, Jetty, whatever. Those dependencies in a Maven project, the dependencies can be transitive or inherited from the parent projects or from the dependent projects. And so yeah, in a Maven project, typically a module A can use all of, if it depends on B, it can use all of the dependencies in module B without having to explicitly redeclare them. Whereas in a Buck project, you only have to declare your direct dependencies. So you don't get transitive dependencies for free. You have to declare direct dependencies on certain libraries in order for them to be added to the compile class path.
Right, but then how do I know whether I have to declare this or not? Because I don't know what my dependents are dependent on.
But I don't think you. So
suppose I depend on OpenFlowJ. OpenFlowJ might depend on a number of steps that I don't know.
Yeah.
I know only that I depend on OpenFlowJ. So how should I go about that?
Yeah, I mean, I guess the question is whether dependency management is sort of another sort of orthogonal piece, right? Which Maven kind of builds in. Maven builds in a artifact repository, dependency managed solution, and build framework. And in Buck, the build framework piece looks a little bit different. Dependency management is slightly more manual, and there's no explicit repo, or you can use the Maven repo for managing artifacts. So yeah, I mean, I guess that's probably like a bit of an introduction. The state of where we are right now is that we still have the POMs all in place because we were waiting till we resolved sort of the remaining outstanding items, both in terms of improvements and code build coverage in Buck before those get deprecated. But it is sort of a high priority item because maintaining both of these builds is a bit annoying. In terms of authoritative build, you know, for testing and stuff and for releasing, we're using Buck. However, there are still plenty of people using Maven to build.
But we would still continue publishing Maven artifacts, right? Even if we
Right. So yeah, like I said, Buck does not bring about its own artifact repository, and so to use the Maven style artifact repository is still part of the plan. So
still app developers can continue consuming these Maven artifacts, and they can, like, if their projects are small, then they are free to use Maven itself.
yeah. So app developers can certainly use Maven. You know, use whatever build they can use. Gradle, they can use Maven, they can use Make. You know, whatever they want. There's a whole list of other dependency managers for Java projects and stuff. Now, the question is, you know, how feasible is it for a developer? You know, what are the workflows we want to support for local development? So if you're trying to build an app against the latest release version of ONOS, then you can just point at the artifact that's released artifact. If you want to, you know, use Gradle or Maven to build your app locally against the locally built version of ONOS, you have to find a way to export the ONOS dependencies that you require to a place that your local app could have access to them. And so in the case of a Maven project, that's the M2 repository, and depending upon the build framework or modes we want to support, that is definitely a consideration. But I mean, the M2 repository is, I think, pretty widely adopted as just a place where local or remote artifacts can be staged.
Okay.
So yeah, there's no Buck repo for artifacts, and yeah, in fact, you know, we use Buck to publish to Maven Central. It's not actually anything more than like a REST API. You define you open a staging repository, you post some objects to it, and you close the staging repository, and then you can mark it for publishing. But you could write a curl script or a Python script or whatever you want to publish these things. And like I said, all a Maven repo is it's a base URL plus the / separated group ID. So it takes the dots of the group ID and puts slashes in, and then the version number is a folder, and then the artifact name and the classifier and the extension. So there's a deterministic mapping between sort of the URI for a artifact and its group ID. Or sorry, it's Maven coordinate. So yeah, I guess the that's kind of the overview for the build system. The other thing on this point is sort of OSGi. So OSGi, Java framework for managing class paths, basically. At its root, really all OSGi does is it consumes jars. It looks in those jars for a manifest file. In the manifest file, it describes a list of packages that it imports and packages that it exports, and the versions that it depends on, and the version that it's exporting. And then what the OSGi runtime will do is it basically maintains a mapping from package to jar, and then when you try to load a jar into the system, it will maintain the sort of the jar's life cycle. If it has all the dependencies satisfied, it will build a class path for that particular jar and start it. If there's like a circular dependency or a loop or something,
you go ahead and it will take care of resolving dependency before.
Yeah, it'll take care of resolving dependency before the jar gets loaded, and then when you deactivate a jar, it'll enable you to do whatever. Now, the other thing that we use that kind of heavily in ONOS. The jars that we generate are OSGi compliant jars, and that basically just means that you take a normal jar and you add some stuff to the manifest after doing some analysis.
So that's the diff that you have done on top of normal buck.
Right. So normal buck just generates normal jars, and we use a tool called bind, BND, to do analysis of the jar and generate the appropriate entries in the manifest to make the jars OSGi compliant.
So this is nothing but the same way how Maven.
Yeah. So yeah, Maven also, the Maven bundle plugin uses the BND bind library to generate OSGi compliant jars. Yeah. So when we talk about, what was it? Just a small tangent. When we talk about what was required to move from Maven to Buck, what we needed to do was we needed to first resolve the transitive dependency problem and build an explicit dependency list for Buck to consume. The second thing we needed to do was we needed to take a lot of the Maven plugins that we were using, like the Maven bundle plugin, SCR plugin, and a few like the ONOS OER packaging plugin. And we needed to extract the functionality into plugins that would work in the Buck environment. And the third thing we needed to do was we needed to take the POM files and then generate corresponding Buck build files that were capable of generating artifacts based on the same set of inputs.
POM to Buck converter.
Right. And there were a couple of projects that helped with the dependency management, and there were a couple of projects that helped with the POM to Buck conversion. In general, what we did was we just tried to leverage the Maven assumed paths. So Maven has assumptions about, or baked into Maven is the file directory structure. So we were able to just use macros in many cases to just pull the same subset, like the same source directory, same test directory, stuff like that, and just infer that for the Buck rules. But going forward, it's possible to build pieces of the source tree that don't necessarily adhere to the Maven specification.
So what exactly is the difference between the OAR and OSGi jar format? Like, are you having any extra headers in the manifest?
Right. So back to what exactly is required to get a jar running in ONOS. So one bit is the OSGi analysis. So we do analysis of the jar. We look at all the import. Basically, what the bundle plugin does is it looks at all the imports. It looks at all the imports, and it looks at all the packages. And then it basically makes a list. Okay, in this jar, there's certain packages that are imported in other classes, but they're not explicit imports, right? So where are all the packages that are not present in this jar? Those are all the imports. And then depending upon, in terms of what versions those are, it can infer them from the artifacts that are on the class path at the time of analysis. So typically, to run the bundle plugin, it'll build a class path with all the artifacts that are required to do Java compilation. If those are OSGi compliant artifacts, it can look at what version of the packages are being put in. Now for exports, you give it some information at the time the artifact's being created about what version of the artifact this is. And then that version can be included in both the manifest as a version string as well as can be included in the export as well. The other thing that we do is there's this notion in ONOS of services and components. And there's another package that's present in a lot of OSGi distributions, which does component management. And so the idea with components, so OSGi does kind of package level jar version mapping. Components are, okay, now I have these little classes within my jars that I want to basically run and wire together, both within my jar and across jars. And so there's one implementation of this called Felix, which comes in Graph by default. And what Felix does is it gives you an activate and deactivate method, and it gives you a bunch of annotations. You can annotate something as a service. You can annotate things as components. You can implement services in your components, and then another phase of our OSGi plugin is to actually look through the various components and services. Basically, find all the annotations that are relevant. The @reference annotations, @component, @service annotations. Auto-generate the XML file which describes these components and is present in the jar, as well as actually like all the set methods for the references get bound in, get rewritten into the bytecode. So there's actually some bytecode modification that happens to add the setters, the bind and unbind methods for all the services that are at reference.
Okay. So this ONOS applications that you package as OAR, right? They are nothing but just OSGi compliant jars, or are we adding any other extra? It doesn't know extra.
So we get an OSGi compliant jar, right, which has the manifest information for the OSGi stuff. It has a features XML file, or no, sorry, the component SCR XML file, and then it has all the classes in it. Then when we take that and put it in OAR, we're actually currently there's a way to have like a single jar OAR or a single jar app, but what we're actually doing for like the standard OAR setup is we're staging the bundles in an appropriate directory to mimic the M2, the Maven repo hierarchy. So we put the jars in the appropriate place in the hierarchy, and we also add two files at the top level. One is a features XML file, which is a way to group jars or group bundles, aka jars, into groups and start them and take them down together. And the second part is an app XML file, which is some metadata for the ONOS application subsystem. Okay. Things like the description, the features that are included, the name, the version, etc. So theoretically, if you have just a single bundled jar, the features XML is kind of irrelevant or could be inferred. And the app XML could just be metadata that's included in either the top level of the jar or in the manifest itself.
So yeah, the question why I asked is, if I understand correctly, whatever artifacts that we are building out of Buck, they are just OSGi jars. They are not OAR, right?
Well, so Buck builds both, right? First, it builds all the OSGi compliant jars,
So
and then
jars, then this OSGi jar bucklet converts that to a convert the jar into OSGi jar, and that's it, right?
So, I mean, one of the build rules, right? The OSGi jar build rule, build an OSGi compliant jar. Then one or more of these jars can be put together using the ONOS app macro. And the ONOS app macro generates the OER files that then can be loaded into ONOS.
So you're still generating OER.
Yes. So I guess we have the deep dive tomorrow where I can actually like show you the difference between like built-in buck rules, the plugins, an example of like a plugin rule, and an example of like a macro which we wrap in buck lists, and kind of like the levels of exposure that you have. So I can prepare that demo for tomorrow.
Yeah.
For
tomorrow questions, yeah.
Yeah. So for I think Maven and Buck sort of talked about OSGi and how that's related. We talked about basically in both Maven and Buck we're using the same underlying open source library called Bind to generate the compliant jars. Bind also has the ability to accept like additional plugins, and there's a plugin to Bind that does the SCR. Okay. There's also another thing that we do where we generate the config, default config files, which specify the default from some of the annotations in the source code for properties that are going to be set. But yeah, I can definitely point you to the source code both for the Maven version of the plugins and the Buck versions. Okay. For the ONOS build system, I mean, do you want to go into more than the frameworks, or was there something else?
I think with respect to overview, I think we're good. So probably we'll take a deep dive tomorrow. So Alexis, like, have you tried building ONOS? Alexis and Jenkins.
I developed an app on top of ONOS.
Yes, I've built it before, but I was building on the older versions like 1.5. The latest one I've built was 1.6, but it was still on Maven. I've never tried with Buck. I think Buck is a very recent probably at the end of 2016, if I remember very well.
Okay. So probably I can give a quick overview on how to build Buck. So if you download the new source code, right, so this is how the master looks, and so this is the master Buck file that Brian was talking about, and then there are some Buck config files that will be hidden, so that actually ties this build with a particular Buck version. So your Buck version and other stuff will be held here, and that is how we are able to get some deterministic output whenever we are actually trying to build using Buck.
Well, so to walk through this, right? So this Buck config file. It specifies a few things. One is the first part for build file. You can ask Buck to include some additional basically Python files into its startup environment. And so one of those such files that we're including is this default defs file, which is how like macros, basically Python functions, shortcuts, can be included in the overall build. The second one, plugins. So this is part of Buck that we extended. We basically have a mechanism by which Buck can inject additional jars into its runtime which extend the functionality of Buck and give you the ability to write new native rules without having to rebuild and redistribute the whole Buck runtime. And Java, we source level, target level 8. We have some aliases that are defined, which are basically shortcuts. So in Buck, you can have arbitrary aliasing that enables you to have shortcut tags instead of the fully qualified paths. And Maven, the default Maven repo can be changed when you're constructing the Maven URLs from the Maven coordinates. Project settings, if you use Buck project to generate the YAML file. Yeah, exactly. And download, by default, Buck doesn't download the dependencies. As part of the build, it will throw an error saying go fetch dependencies. This just says, ignore that. Just go do it. So this is configuration that everyone in the project shares. If there are specific things that you want to override, for example, if you wanted to limit the size of the Buck cache to a gig or 2 or 3 or 4, you could add a cache line in a Buck config local. If you wanted to restrict the amount of cores that Buck could have, there's a whole bunch of properties actually in, if we go to, so Buck build. So under here, there's so there's a whole set of descriptions for for the various build languages for C, Go, Groovy, whatever. There's build language specific configuration that you may want to do. So basically, config goes in Buck config, or in the case of if you want to have a local file that's not checked in, that will override the config that's present for the main project. So just to follow kind of how the environment looks, if we go into tools, defaults, yes. What this basically does is it defines many of the Bucklet files that we have. So ONOS defs is just a list of all the core modules, the apps, the plugins. So what this is doing is seeding the environment so that any of the regular build rules can start to use that. So if we look, for example, at ONOS defs. Right. Here we have the default group ID, the version that's going to get baked into the artifacts.
So if they spin up a new version, all they have to do is just change it here and then change everywhere.
Exactly. Changing it here will mean that this variable, wherever it's used, ONOS version, wherever it's used, will be put in there. And then if we say look at modules, we have groupings of modules that can then be used to so you don't have to specify these long lists. So you can think of it just if you think of the Buck environment or Buck more or less user-facing surface as being kind of like a Python environment. Buck's core is actually written in Java, but if you think about the runtime, where you build your Buck rules and stuff as being a Python environment, what we're effectively doing is we're defining some variables, some Python variables that are going to be, and variables and functions that are going to be made available at the time that your Buck files are being executed. Yeah. And so, for example, if we quit these two, there's also Bucklets. So we can look at the ONOS Bucklet, for example. This defines a few more variables at the top, and then these defs here, for example, def check style, is just a Python function that is going to take some inputs and it's going to produce sort of a more complicated combination of build rules, so that at a high level, the rules that you're writing don't have to be as complicated. So yeah, if you think about kind of bucklets being the place where simple plugins can be written or combinations can be done to sort of extend the runtime environment for your buck files, and defs being kind of a place where you can dump your high-level environment variables. That kind of sets up the environment to do the rest of the build. And then, for example, when you actually invoke buck, what happens is there's a Java process that does the heavy lifting. That's where the native plugins get, or native build rules get implemented. And that's where it manages the dependency graph and also the schedule. But part of that process, like for example, let's just do a build, buck build, right? So the first thing it's going to do is it's going to go through and it's going to parse the buck files. So what parsing the buck files means effectively is create the environment, like with the variables and the macros that you've defined, and then go through all the buck files you can find in this directory target. In the case of ONOS, is actually a macro to package. So it's going to kind of go through discovering all the different files that could be present.
Another important item to note here is that if in case of Maven-based build, it is important for you to download Maven and install it and have it in a path that is set to buck. You just have to download the code, and then when you start this buck process, it looks whether buck is there. If not, it will actually download it. So it's like all you need is to have just Linux, and then once you get the code, automatically buck gets downloaded and built. And then every time when this thing is changed, when this buck file is actually tagged to a new version of build, new version of buck version, or if they have done some changes, then automatically it will discard the old version, it will get the new version and it will start. So it's very self-sufficient build. So like you don't have to have any kind of prerequisites.
So yeah, the first part here, which is processing buck files, means go through the buck files and basically exec those Python scripts. Buck files are basically Python scripts. Exec those Python scripts against the environment that buck is built with the variables and the macros that you have. So this part technically doesn't need to be done every time. We force it to be done every time because there's a bug that we need to address. But basically, you can watch the file system. BuckD, exactly, and it'll track changes to the buck files. If it sees changes to the buck files, then it'll force a reparse. But if there's no changes to the file system, it will not force a reparse. But so that part you're going to pay in this case because we're not running buck daemon. We're gonna pay that every time. But in the future, it's possible to bring that down. That's just an optimization that could be done, making it work. So.
So can we have bugs running in distributed fashion? I think like I have some, might not be applicable for ONOS, because ONOS code is not that much big. But what if in future, like we have some 10, 15 different kinds of projects trying to build using same bugs. So I think if that's what Thomas said, or he is referring to something else, like having some distributed build using bugs. A collection of bug servers who is actually monitoring some nodes, and whenever something changes in that node, then automatically the code gets pulled and then compiled automatically.
I'm not.
Instead of bug running, bug D is nothing but a daemon working on a file system, right?
Oh, yeah. But the thing is, BuckD doesn't actually do any build work. It just monitors so BuckD, if you run BuckD, is just a daemon that does monitoring the files on the file system and looking for changes, because it knows if the file on the file system hasn't changed, then both the buck rule and the underlying files don't need to be rehashed. And so if you look at like where the time is spent on this build, so on my computer where I have an SSD, and I don't run BuckD anymore because, like I said, there's a bug right now. But when I was running BuckD and with an SSD, the incremental build time is like under a second. Now for me, there's a bit of processing, so that processing gets paid sort of for every build. So there's definitely a reason to invest in that. But then the build here, you see it takes 16 seconds for your build. And what that's doing is it's effectively computing the hash over all the inputs. So that's all the file inputs as well as the meta inputs to the build rules. And then checking its local cache because it's already done the work. So here, it hadn't been done recently. There were some changes, so 46 seconds the first time, 16 seconds the second time. The download line's in there too, because if there's artifacts that are referenced that are from the internet, there's a download phase before it can start building. But yeah, so the first part, processing buck files, is literally just parsing the buck files, evaluating the Python code that makes up the buck files. So that the code in the buck file should be kept, as lightweight as possible, because that's paid sort of every time. Then the build phase is where it actually now has the graph, the directed graph of rules, and it actually goes through and starts evaluating the rules that have all their dependencies satisfied. So for the rules that have all their dependencies satisfied, it just schedules them on the available executors. So by default, you get one per core. It'll just start scheduling things on the executors, and as things become available and new nodes in the graph become unblocked, then they get scheduled as well. So it kind of like what you see here, you've got two virtual CPUs on this VM, and so you get 2 lines of parallel running. If you had more cores available, like on a machine with 16 cores or 24 cores or something, you'll see many more of those lines parallel. But I think your question was, okay, I have like a build cluster or something. I want to do like builds and stuff, scheduling. That's kind of a feature of Blaze, but not really something that's present in Buck, and I don't think really present in Bazel. Now, one of the things you can do is there's a mechanism for having shared cache. So the rules that get generated can be put in a cache. And so having a shared cache between the cluster of nodes that are dedicated for doing building would mean that work doesn't need to get replicated in every one of those nodes. They can pull from the cache. It's also possible to have developers who are in like the same geographic location share a build cache to make their build a little faster. But it's really important if you're going to turn on distributed caching that the rules you have are completely deterministic.
So that's how you build ONOS using Buck. And then if you want to run ONOS, just
So what is ONOS and what is ONOS local here? So ONOS here is it's sort of an artifact that is dependent on all of the jars that ONOS is sort of builds, as well as all the apps that we include by default in ONOS.
This package is install.gc format and then
It includes
in some place.
it includes Apache Carafe patched to automatically start up ONOS. It includes all the artifacts in the system directory for Carafe, and it also includes a few scripts that are sort of useful for starting, stopping, running ONOS, as well as like the init scripts and stuff. So yeah, so ONOS is like this big tarball that you can download from the project website. ONOS local is basically a bash script that knows how to start ONOS in this local context. And so we have basically this nice wrapper target that can take the output of the tarball and run it. So you don't have to go and like spin up the graph or untar it, spin up the graph. This basically just untars it for you and then evokes the graph start command.
So earlier in Maven, style we used to give OK clean.
So OK clean was a macro that basically, I forget exactly what the script looked like, but
it is Maven clean install local and clean.
yeah, so it would install everything in Maven Central, and then it would basically start up a Carafe instance that was pointed at Maven, the local Maven repo for its dependencies.
You still have the star right there.
I've never seen that, so I don't.
I remember someone was actually complaining that and think the way fixed it, but then it still starts again.
Yeah, the other thing we do here is we dump you into the log instead of dumping you into like the almost. Yeah, this is sort of the easiest way to just get started running with the buck-based install. You could just skip all the build stuff and say buck run ONOS local, and it will figure out all the dependencies it needs, build them all.
Just that now it is using the SSH login, so it is like putting a name in the key host file. Like I'm the host, I'm the client, but still I have to go through the route.
Yeah. It easily generates.
This is the pain point we have.
So startup.
Yeah.
Yeah. So you also have like your updates when you're running your too, from your CPU.
No, I have given some. I have given less resources.
Yeah, there you go. There's
So I was talking about this, right? So this one, like I'm the host. It is still local host, but even not to connect to the local host, I'm actually putting a key in the host file. So do you think it is a roundabout way to access the console?
So in Graph, there's like two ways into the console. One is SSH union, and the other one is to use the Graph client. And I forget exactly how it accomplishes that binding. You might still do it using SSH It might be SSH with like a default username and password, or something we disabled because it's
in the previous version, if you just type ONOS, it was actually invoking Karaf client. It does not go via SSH route.
So the question is, what does the code for Karaf client actually look like?
Okay.
And it might be so the client code. If you kind of crack open a Karaf, so that's your Karaf.
Big client. So let me go to VM. Okay, Java.
So this one, exact Java. So it's running this Karaf client main thing.
So it's not taking the SSH client.
Yeah, but what is question is what does this do? Or Apache Karaf. Yeah, looks like it. Just SSH is in with like a known.
Yeah, probably it's using SSH protocol, but it's not going through the SSH system.
Right. So it's it's the same thing, right? Whether you use the SSH program or whether you use a Java program that's going through SSH, right? Like,
but then why there is a loop back in the host file?
oh, like why do we add an entry?
Yeah.
Well, the thing is, if that's what, so by default, the SSH program has a known host file, and it also does host key checking, right, to prevent like man-in-the-middle attacks. Yeah. And one of the things we could do is we could just, for the arguments that get past the SSH program, put -o host key file equals dev null, and -o strict host key checking is off or something, or false. So there was ways we could turn that off where it ignores the known host file and doesn't actually mess with your regular SSH known host file, which is effectively what it looks like is happening in the client that they put in.
Okay.
So yeah, if that's the concern, that could definitely be worked around
Okay.
with a pretty easy patch. I think you just add 2 options and you'd be done. And one of those options may already be set. If you look at the ONOS command in the source tree,
You mean the dev profile?
yeah, I think it's in full dev dash profile. There's a function called ONOS. you do which ONOS from your terminal? Okay, we'll test it. So in here, there's going to be a line somewhere that invokes SSH. Yeah. So if you just said like,
it is strict host key checking is no. It means you have to keep ignore host also.
so that means it's not going to ask you like, do you want to connect to this host? But it's still going to add stuff to your known hosts file. Yeah, so I think it's, if you said user -o user known host file equals /dev/null.
Was it?
User capital U SER capital K known capital H hosts user known hosts file. Yeah, file equals /dev/null. Yeah, there you go. You're in this one.
No. But I should add a new terminal. No.
User.
It's okay. I think if this is running, then it's okay.
Yeah, so I mean we can work through that fix, but that's I mean I think there's ways we can make the script look like the graph client. Okay, so what, I mean I think we've kind of spilled over on our agenda. Do we want to take a look at?
I just thought to give a quick 101 on bug.
Yeah, no, thanks for walking through that. Hopefully it's useful. I mean, does anyone, I mean, Venkat, or does anyone on the call have some questions?
Yeah, I mean, I still have to put my hands on this subject so that I can troubleshoot that.
Okay.
No, this is really helpful.
So Zach, are you also on the bridge?
Yeah, I was just saying that no, I didn't have any questions, and this was really helpful.
Oh, okay. So it was Zach who spoke, not Alexis.
That was Zach, yeah.
Okay.
No question.
Okay. So Agnes, okay.
Okay. Yeah, I think tomorrow we'll revisit this and we'll sort of explain, like I said, the plugins, the macros, and kind of like the anatomy of a build rule, how it gets constructed and what it's actually doing. But yeah, thanks for kind of just giving people an overview, because I think that helps ground some of this. So, do we want to work through this break? Do people need a couple minutes for anything? Or? I think we're good here. So, all right. So we move to the next item.
Yeah. Jenkins.
Okay. So maybe I can start with just the current state of affairs.
Sure.
Right, just so people have a clearer picture of how we're using it today. A lot of this has kind of grown somewhat organically. I guess is the nicest way to put it.
You want me to share pass the ball to you?
Yeah, sure, I can do that. Okay. I'll start sharing my screen. So right now we've got kind of a plethora of jobs on our Jenkins machine, but perhaps I'll call your attention to a couple of the relevant ones. So one of the jobs we have is called ONOS Buck. So this is the job that gets triggered every time there's a new patch set that's updated in Garrett. Yeah. So for example, this particular patch was Shivani updated something, it triggered this build over here. And what's actually happening? So going here. So one of the things that's a little bit unfortunate is the way a lot of these jobs were built was by just manually building them through the freestyle jobs, manually built through the UI. And the downside there is that people change these things occasionally and they break, and it's not like a detailed, who did what when.
So having access to ONOS source code, they're able to change this job?
I don't actually know the group of people that explicitly granted permissions here. That's managed through a crowd group, I think. Luca manages that. So there's some subset of developers that are able to check stuff in here. Now, I think the freestyle job thing was fine when we were first getting started, but actually, like, enabling developers to check in, like, I think these should be sort of version controlled in some way. And I think pipeline's one way we kind of started moving towards that, because now you have the pipeline file that gets checked in and stuff. But I mean, basically, the build's parameterized, so you can kick one of these off if you want, like by hand. But the way that this job almost always gets triggered is a Garrett trigger, and then that's for changes that are 1.6 or later, because that's when we introduced bucks. This is the buck voting one. There's also the Maven voting one that was, I think, up to 1.5 or 1.6. But the interesting part here is sort of what gets done. And so one of the things we do is we create, I guess, I don't know how this got added. So each of these shell commands kind of gets executed in its own shell. And so, to be honest, like this importing of env defaults, I don't even think this shell does anything except for create this temp directory. This shell command, so one thing we do for Jenkins is we have a common buck cache so that we don't have to rebuild everything all the time, because small jobs, like you have multiple executors that can run in parallel. And so we want to maintain like one cache that the executors can share. And so we link in a common cache. That common cache gets referenced through a buck config local file that I was describing before. So one of the things we do is this number, probably should be lower, but we'll only use 75% of the cores when it's determining how many parallel executors to do. We enable parallel parsing of the buck files, create a timeout for tests of I think this is a minute per test, and this might be milliseconds per test, because by default buck will just running, and sometimes you have infinitely tests. Then we basically do buck build ONOS. The reason why this buck is we wanted to force it to use the buck that is the script-based buck. Like if buck is present on the path, you want to just use the one that's present. And then we run the build of the docs, and there's like a new way to build the docs, and there was the old way to build the docs. So this is sort of some legacy code before we just kind of like queried for all the Javadoc rules and then what will happen is, because it's a trigger-based job, it will go off and it will vote whether this failed +1, -1. So this is basically, I don't know, a pretty simple job that basically just runs buck build ONOS buck test, which will run all the test targets, and then the Javadoc. Test includes unit tests and test style. So then there's also another job that runs periodically called master, which, to be honest, might be pretty similar. This one runs every 15 minutes if there's, or it pulls the Garrett every 15 minutes. Or
excuse me?
Yeah.
The previous job, ONOS Garrett back,
yeah.
What triggers the build? Is it whenever there is a commit, there is this job? What triggers the build of the job?
Yeah, so what triggers it is Garrett. So every time there's a new patch that shows up in Garrett,
suppose you make a change and then you just push a patch set for review, it will first trigger this Jenkins job, and then once the build is passed, and then only it will move to the review stage.
Okay.
Yeah, so the way that's actually implemented on the back end is that so Garrett has like an SSH API and an HTTP API and stuff. So there's this stream events thing where you can basically just ask Garrett to like stream updates to stuff. So for example, if we went over here and created like a new patch set, I don't know. There was a new patch set. Great change, here we go. So master test create publish. So see how there's these JSON messages that we as a streaming event user get. So the first is there's a ref created. Next one, there's a patch set event, another patch set event, a patch set created event, graph published event, and I think the first one is a ref created event. So anyway, the point is that Jenkins establishes an SSH connection to the Garrett server, and then just subscribes for all the events that are coming. And then on the Jenkins side, you can tell it, well, I want to trigger on patch set created events and draft published events. And then for every one of those events that comes in, Garrett will automatically trigger. And then it's got a bunch of details here, so patch set created event and a draft published event for that matter, where it knows the uploader, it knows the patch set, the revision, it knows the refs that it needs to do the clone, and it knows the change ID so that it can vote. And then it'll run the job, and then when the job's complete, so like if we look at this one, we have one running now. This is my new patch set that I did. So first thing it does is it fetches the change, and then it runs the custom config stuff that we were doing. It gets the executable of buck that is targeted for this particular change. Then it runs the build. And then when it gets through that, it'll run the tests. When it gets through that, it'll run the Javadoc. And then, I mean, from a workflow perspective, you need to do the build first. But then once you have the build, you can do the tests and the Javadoc in parallel. There's another step that we hope to add, which is we currently have STC for running some integration tests. and we want to be able to run some of those integration tests as part of these Gerrit check-ins as well. So there's a couple minutes, like a 1 or 2 minute integration test suite that we want to run in parallel to the check style, unit tests, and Javadoc stuff. But yeah, then we'll start seeing the test results. So these are all the unit tests, pass, 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 whatever. And then once the unit tests are done, we'll go to Javadoc. And then what will happen at the end is it'll say build success or failure. And then that Jenkins will then log into Gerrit and post its verified +1 or -1.
As a Jenkins user.
As Jenkins user, yeah, exactly. Yeah, so Jenkins has an account on Gerrit, and then the credentials, the key pair is on the Gerrit machine. And so with that, it uses that to both establish the stream events session, as well as post it there.
So now the inference here is there, all you need to do is convert this street-shell job to a pipeline-based job.
Yes, that's definitely something that could be done. And with the pipeline-based job, you know, the various building blocks, like we mentioned before. One thing that's nice is that the building blocks for the Gerrit validation and for the validation of the master branch would overlap, right? So the pipeline stages, as I understand it, you know, could be shared between various pipeline jobs, and then you just can have job configuration that define what happens in sequence and what happens in parallel. But I mean, fortunately, we have kind of these building blocks here that perhaps could be split up a little bit, but which do define the build process, test, and then the Javadoc step as well. And then we'd like to add the what we call STC integration test. So yeah, back to the dashboard. I mean, the Gerrit buck job, that's probably one of the more important ones. The Maven one is still in here sort of for posterity. There was one that we started doing, which is off, but that's the Gerrit with STC. So that's one that would try to run the STC command. This may not have been finished. This is something that Ray and I were working on, but it would get some infrastructure in EC2, start the process of running the job, and then report the results. So that one I don't think was ever finished, but it was started there. There's also the sonar job and the nightly. I forget the difference there, but so there's a few. One is the master job that runs. I think it was targeted at running sort of more in the way of tests periodically on master, based on source control changes, and then also potentially uploading some artifacts to snapshot repository.
I have a question here.
Sure.
When you talk about master job, slave job, all these jobs that are on the dashboard are just running on one server, or it's just a cluster of servers?
So currently they're all running on one server. This is kind of a problem because in terms of like resource isolation, sometimes these jobs will consume, you know, too much in the way of resources and generate really high load factors on the machine, which will then cause the UI to time out. But yeah, I think this is all currently just one node. The master node is the same as the one that runs Jenkins. What we'd like to do though is probably have the UI and the master run, you know, on a small instance, and then have a resource pool that's available.
Yeah, but you're talking like you want. I mean, you're thinking like master. I mean, the controller can run in a normal VM, and then the slaves can run on code split across them, and then master can just schedule jobs on whichever code that is idle, so that you can split the load.
Yeah, and I think a lot of people who set up Jenkins do it that way, where they have a small protected master from a resource isolation perspective, and then you have your executors that can do the actual work. So yeah, so currently we don't have that. Currently it's all just through the one node. But yeah, that wasn't designed intentionally. It was more, like I said, because this kind of grew up organically. There's also, oh, go ahead, Alexis.
Yeah, I was saying thanks for explanation.
Mm-hmm. So there's a pipeline job, a job for doing the sonar analysis that gets published to the sonar page. So this tracks like lines of code, code coverage, technical debt by whatever metrics they defined here. Then you get kind of like a drill down where you can see kind of like a health of each of the components from a test perspective or code coverage perspective. So this is kind of useful for people that want to get a sense for overall code health as well as the test coverage for various components. So the sonar job basically just runs, there's basically sonar scanner, just run that plugin. And more or less works. For the nightly job, I forget exactly what this one does, but so this one is the one that is going to upload the ONOS tarball.
So when get like it is also one of our tasks to actually document the CA process. So whatever Ray just explained, has to be converted into a proper doc format and then have it somewhere.
Yeah, so I mean, I guess, yeah, it's a series of freestyle jobs that we do stuff, but yeah, the nightly job, this one is responsible for uploading the tar file to the nightly repository of these things. So people can get the nightly zips or tarballs, as well as uploading the artifacts to the snapshot repo. So sonar type snapshot. So every night we put artifacts for ONOS project. And so, for example, 273, this was published on the 24th at 7:35 UTC. So, or rather, the artifacts up here, 7:30. But yeah, point is that the nightly job is basically just for publishing artifacts, a nightly snapshot of the artifacts for developers. And these are just sort of steps that would be built on top of the existing sort of build it as well. Could theoretically done in parallel.
So I have questions related to this whole point. So,
do you wanna share that?
Yeah, sure. Yeah, so these were some of the charter items that Thomas essentially put up. So there he's talking about development and maintenance of the CA process and release process and supporting tools and working with team managing infrastructure. And the integration of CA with basic functionality test as part of build and release process. So, but I mean, if I understand correctly, we do have a CA process with respect to nightly builds, right? So what exactly is the work here?
So yeah, we have it with respect to publishing nightly builds. I think the bit of work here for integrated CI, yeah. So that's what I alluded to before. So Garrett with STC, basically allowing the Jenkins machine as part of its validation to run our integration test suite, which is STC. So that's basically the request there. And that work has sort of started. Ray and I have both been a little bit involved with that. But yeah, the idea is that right now, like the unit tests don't cover, some of the DOA scenarios where like there's a loop in like the features, or there's a what do they call it? A scenario where like you have one version of one package, another version of another package that gets imported in OSGi, doesn't commit the jar load, or someone messes up like a config file or something, and that just causes. So it's basic sanity tests plus making sure components work together and work in like a basic whatever.
Maintenance and upstreaming of Brigade plugins. I understand about the module owner plugin, but just explain about the stats and project log that you do.
Sure. So the module owner plugin basically is the plugin that we use to grant selective access to parts of the file system to people within the community. So that's a plugin that we wrote on top of Garrett. The stats plugin is just a plugin for like clone stats and stuff, clone and other sort of Git and Garrett related statistics that stream to a database so that we can sort of have some community metrics around like with GitHub you get a number of source downloads and clones and stuff. And that's basically is just, those hooks exist in Garrett. There's no like default mechanism for collection. So that's just a collection. That's collection plugin. Okay. And then Project Lock is a really simple plugin that sort of gives a user makes the user the only user that can submit to certain projects, which is useful during like releases. So you can say like lock this project or this branch or whatever. It's locked by me. It's locked by me, and then it'll block submits from our users. So there's just three plugins that are listed on GitHub actually. That if there's an opportunity to work on those or upstream them.
So when you say upstreaming, then it means like the concept itself is confused here. Or you said that they are hooks, so I was thinking that these are just implementation of the hooks, but not the hooks themselves.
Well, so here's the thing: stats plugin probably isn't going to get upstreamed because it's like just leveraging the hooks and like it's a pretty simple like integration of from Garrett hook to database or something, right? For the module owner thing, it's a plugin like any other Garrett plugin that could be generally useful to the broader community if it was properly documented and stuff. But Garrett has a section in their code tree for plugins, and so they accept plugins from outside contributors, and it's something that we just haven't gotten around to doing, but could be interesting. And Project Lock, sort of something similar. Not something that like the way to block other contributors out of a project is or out of submit would be to write either some prologue or to modify the configuration Git repo. But this allows you to do it sort of with just an SSH command, which makes the process of blocking a particular branch during whatever releases or something a lot easier. So that could also be something that's more broadly useful to the community. But I think those are sort of secondary objectives. I think it's more like, you know, if there are new features or whatever that are required, that can be done. And obviously, when for upstreams, you know, maybe other communities start, you know, start some improvements or they get maintained or something. I don't know.
Shared cells warden.
So shared cells warden and STC integration, you know, could be considered related. So to give you some context there, shared cells, in the lab here we have 3 servers, 3 physical boxes that we've split up into, I forget how many cells, but so for people that are on the LAN here in the office, there's a mechanism by which they can get some shared infrastructure that's well provisioned for running an ONOS cluster. But you have to be on the LAN, and the boxes are located right here. Now the question is, for the STC test that we're going to run on Garrett, or rather the Garrett trigger jobs that run on Jenkins, getting some infrastructure to run the tests. How does that work? The other thing is, like, if you have a developer that's working remotely, you know, is it possible for us to provide this sort of infrastructure to them, where they can hook up, you know, their EC2 account, or I don't know, for partners or something, have some amount of resources that are available for the community. This would also be useful for things like tutorials or demos, where you have some infrastructure that can be spun up close to where the demo is happening, so you don't have to rely on like a VPN, or you don't have to rely on like the high latency from like China, or the fact that the connection is blocked or something, or you know, or India or Europe, or for, you know, forever, right? Like latency at Menlo Park is not the greatest. Yeah, the idea here is that there was this warden code, which is basically a broker for these cells, which Thomas wrote as a mechanism to share the cells within ON.Lab. Maybe I can give, I'll give a quick demo. So, for example, yeah, they just took it back. But if you go back, so kill that. So if you do cell, you can see that in the lab, there's 1, 2, 3, 4, 5, 6, 7, 8 cells. User U is using this one, John's using this one, Jordan's using this one, Treya's using this one. And if I say cell borrow, what will happen is one of these cells that's available is going to get provisioned for me.
Like taking from someone who is not using it and using it.
Well, so yeah, on that machine there's some compute available. So now if I say cell, so I got a cell. Sorry?
Yeah, I'm a little bit lost. So you are now on Garrett server, right?
No, this is my laptop.
Okay, so what do you call cell? What is cell?
Okay, so yeah, that's probably worth explaining. So when a lot of us in ON.Lab do development, we'll work locally on our laptops. So we'll run the build commands like just using like our laptops, because most of us run Macs and it works fine. Now for people that are on Windows, unfortunately the build and run doesn't really work as well. or at all on Windows, so you're kind of stuck using a VM for doing the builds. You could still use, you know, a native like IntelliJ or Eclipse or whatever development environment you want to do source code modifications, obviously. And so, like Vishwa earlier showed, a really easy way to run ONOS before is to just say buck run ONOS local, and it'll run a single instance of ONOS on your laptop. But if you want to run like a cluster of ONOS instances, like 3 nodes or something, I mean, there's a whole bunch of different stuff that people have done. Like, for example, there's one way that you can spin up like 3 mininet nodes and then connect them together and connect them to a test network. A lot of people have used LXC and built like 3 LXC containers or 5 LXC containers in a VM and then run their stuff in LXC. There's some people that have explored using Docker and running multiple Docker containers and networking them together. And then some people just have like a bunch of VMs, like they'll run like 3 different VMs on their laptop and then they'll run almost each of those VMs or whatever. So yeah, ONOS is mininet nodes, yeah. So there's a bunch of different mechanisms people have for running sort of clusters on their laptop, but it requires that you have sufficient amounts of compute on your laptop to handle it. So like a beefy laptop can handle 3 nodes pretty much, but a lot of the laptops that developers use can't necessarily support that. And so we have this concept of a test cell, which is basically some virtual containers or some containers on some shared infrastructure. In this case, we have, so a cell basically is like a collection of containers that together form the resources required to deploy a cluster for testing.
So these cells can still be distributed. Like when I see what you call OC1, OC2, or OC3, they're not necessarily, they can be on different nodes, right?
Yeah, they can really be anywhere, right? And so a cell is, like I said, literally just a collection of resources. And so in this case, I just happened to borrow a cell from our local environment here, and I was given back the IP addresses of 3 containers that are running on one of the 3 servers in the lab. But theoretically, yeah, OC1, ONOS controller 1, ONOS controller 2, ONOS controller 3 could be 3 random addresses on 3 disjoint pieces of hardware across 3 different networks. The only thing that's important is that these containers have network connectivity to one another.
Okay. And
then in this case, there's also what we call OCT. So there's like a test harness, and the reason this exists is. Not yet. Oh, we're on where were we? Yeah, Zach's on this one, but we're covering Jenkins and cells and kind of what we require to run FTP as part of Jenkins. But GitBooks is going to be more or less next. But you're welcome to work here and join.
I feel like I earned my meal.
So yeah, the test node harness is basically just a node that if you needed to SSH to and get access to the cluster, you could push the bits there, and then from there to the other nodes. For example, if the bottleneck was between you and the network that's hosting these containers. There's also OCN, which is a node that we will basically run a mininet network on.
Yes.
And so, yeah, OCN runs mininet. OCT is basically just a node you can use as a SSH proxy. And then the OC 1, 2, 3, 4, whatever, are just basically the IPs of containers where you can start an ONOS instance. And then you can also define like a set of apps that you want to be automatically started. The ONOS user and group, these are sort of environment variables that will get pulled for various scripts, like the ONOS login script, or the ONOS app scripts. And then the ONOS NIC variable is basically just a variable that helps ONOS figure out what interface it should use for the intra-cluster communication. Scenarios is a directory of the integration tests. Topo is what is used to spin up the mininet cluster, what topology should be there. Web user, web password, or logging in for some of the requests that do curls. But yeah, basically, so you can think of a cell as just a collection of resources. We have some shared collections of resources in the lab. And one of the things that we're trying to do is enable people who want to use this this tool chain to do development on their own resources, give them sort of the binaries that are needed to get that done. And part of that also is running potentially the cell manager or broker, aka warden. Like, I don't know, there's a jail theme there. The warden's got the keys to the cells or something, right? But yeah, basically have a mechanism by which that warden code can be deployed on either like cloud infrastructure like AWS or in like private lab infrastructure, so that developers in partner companies or whatever who have resources at their disposal could more easily gain the resources that are required to build ONOS clusters. And if we kind of use a shared mechanism, I mean, I'm not necessarily wed to the way that we've done it, but if we have a shared mechanism for doing these sorts of development and test deployments, the tooling to help facilitate it for developers and for sort of DevOps types folks that are putting stuff into production could be more streamlined. So I was just, yeah, this is just a demo of sort of the lab we have here. So if I say cell status, now there's a cell here that's been reserved for me, and I can easily deploy ONOS. So if I said, so STC is the system test coordinator. It's a basically another one of the integration test framework that we built in-house, and basically it's got mechanisms to understand the cell environment in the form of environment variables, and then push ONOS to those areas. So now, as a developer, I don't necessarily have to run this stuff on my laptop. I can get bigger cells without running the fan up to infinity. And so, go ahead.
Are these tools, is this something that you guys developed internally, or is this something that is available?
So STC was developed internally, but it's available as sort of a separate project. The scenarios that I was talking about are XML files. So, for example, there's a setup scenario which sort of describes the step name and the command that needs to be executed. And then the OC variables are the, in this case, the cluster nodes that should be running all of them. So this is something actually mostly developed by Thomas. So if we wanted to kind of do more of a deep dive on STC, we can go find him and pull him into this meeting, or find some time on the schedule and do that. But yeah, I mean, there's plenty of other tools that could have been used, I guess, to do this type of deployment, and maybe there are some advantages to using standards that other people are familiar with. But yeah, STC basically it's written in Java, so there's a Java binary that is used to sort of execute the tests, and then it parses the XML files. And
the maintenance of this shared cell solver also comes in the scope of this Brigade, so it will be worth to invite Thomas. Maybe not today.
Yeah. So yeah, both the Warden stuff was initially developed by Thomas, and the STC stuff was initially built by him. And so I think it sort of evolved from systems he's used in the past to do the sharing of infrastructure and to do sort of the integration type testing. But there may be sort of other open source options that do more or less the same thing, which could be considered as well.
Okay. Do we need to load the ONOS? I mean, how do we launch the ONOS on individual containers itself?
Sorry?
How do we launch the ONOS on individual containers in the set?
Yeah, so the way that's done is
If I understand correctly, even the development, most of the development do happens on my laptop itself. Okay, but if I want to test it,
only deployment,
right? So how do I transfer my custom built ONOS with my own changes?
Right. So this is a case where if you look at kind of the tools directory, there's tools dev, there's tools test, there's tools package. There's a bunch of bin. There's a bin directory within a lot of those, which have a bunch of shell scripts.
Okay.
And yeah, so rather than use a lot of any one of these sort of open source or otherwise choices, Ansible, Chef, Puppet, whatever, for doing these sorts of deployment of software to the containers, it's mostly just Bash that is aware of the cell variables and will log in over SSH and use SCP to deploy bits and stuff. So again, this, that's kind of the way things were done. Sort of the path least resistance at the time. A lot of that stuff was written by Thomas, and it would be good to get him into some of the discussions about if we want to move to something else. But yeah, I mean, it might be entirely possible that a combination of instead of creating these ONOS, we could create ONOS Docker images. We kind of already do in some cases. And then have, scripts that already know how to deal with the deployment of Docker images to shared environments like Kubernetes or Docker Swarm or something. And basically just use, I don't know, whatever. There's a million, orchestration, shared infrastructure, container type frameworks, and maybe some of those work well with cloud-based stuff. I don't know. So, yeah, I guess a lot of this stuff was just kind of written at the time. It kind of uses this notion of a cell for pulling the environment information out of, and then that's kind of where we go from there. But I mean, perhaps it might make sense if we have some time later in the week to pull Thomas in and do kind of an explanation of STC, Warden, and the deployment scripts. Yeah, maybe Zach. It sounds like you might be sort of more familiar with a lot of this stuff, and so it'd be good if we found a time that you were available for that discussion.
Yeah, sure. Yeah, this looks pretty similar to some other things. I just the actual background, it's using LXC on some nodes that you have, and it is automating that whole process of allocating and then tearing them down. So
the Warden scripts currently do that exactly. It's LXC containers, and basically it just it basically clones the containers, tears them down when the reservations are returned.
Okay, and then builds all the networking in. Yeah, we I've seen other things, but it's always interesting to see how people come up with solutions to that.
Yeah, I mean, I think from my perspective, the biggest challenge with these container management platforms is that they have very little control over the networking, and a lot of it's port based. So you bind a port to an IP address, or you put. I mean, I guess Docker finally introduced user networking, but it's still kind of complicated to set up. And not to say that the LXC-based solution that Warden employs is sort of the most sort of easy to use or at least complicated. But I don't know. There's definitely, I think, an opportunity around that.
Yeah. Okay. Yeah, that sounds good. Just because it is a test tool, but I guess it depends how much work we're going to end up having to do with it, with the rest of the build system, because I'm assuming that none of the Jenkins jobs or any of the other build processes touch this. This is for one-off developer-centric testing.
Well, yeah. So I guess the question here is that this environment is used sort of within ON.Lab and sort of for developers that are on premises to do some degree of testing. There's a sort of one of the questions is whether this sort of environment would also be well suited for something like the Garrett-based validation jobs, for the Garrett-triggered validation jobs. So when you, like, if you wanted to run the same set of tests across, every check-in that comes into the project, which I think there's some interest in doing, is having this sort of shared warden the right approach? And if so, should we deploy an instance of it on EC2 somewhere where you can just have the jobs reserve a cell, execute the test, and then return the cell, make that sort of make that VM or container or whatever available to subsequent jobs, and whether I guess more broadly whether there's sort of an interest in kind of having this infrastructure available to people that want to run their own instances of it for their own development. So yeah, I mean, basically we could say no, it makes more sense to run something else in those contexts, and I think if that were the case, we could potentially move the ON.Lab based workflow to that standard or whatever, or we might say, yeah, it kind of makes sense to have this environment for other people to use, and then maybe there's a little bit more investment that needs to be done.
Okay, that sounds good. I don't have any other questions.
Okay. All right. So maybe we want to go to the next agenda item.
Yeah.
Who should I pass the control to?
Can you give us some introduction and GitBook? It would be good if we have Ali, because he was the one who proposed GitBook. Yeah.
Well, I don't think we're gonna get him, so. Last I heard, he's still wandering around Mexico.
You pass the ball to me?
Oh, to you? All right, that's to you, then.
Okay, so I'll just take you through some of the points that I know about GitBook. Alright, so one of the charter items for this brigade is to actually maintain documentation with respect to the build user and the OSGi documentation. So these are the three items that we are targeting with respect to the GitBook. So the point here is that even though we have wiki, but currently it is not so easy for us to find information that we want whenever a new developer or a newbie, ONOS newbie, just get into wiki. And then since we are not maintaining any versioning in wiki, so it is very tough to actually see like what are all the new features that have been released as part of a particular release. So we have the release notes, but release notes are something like the pointers to the feature, not the elaborate description of how a feature can be turned on or turned off, or the nitty-gritty details of the docs there. So the idea here is to move slowly from wiki to GitBook kind of manual, wherein like for every release that we are making, that particular information will be available as part of GitBook, and the information will be checked in as part of the release so that it is also version as well. So as part of CA release, what we want to do is to get our hands dirty. So like take a blog post or take one particular section of wiki and then try converting it into a GitBook and then put it out in the community to get the feedback or comments, and then start tuning or start converting more and more information from wiki to GitBook. So that's the idea. And on a similar note, teaching Brigade is also looking forward to actually take some contents from the wiki and then organize it with respect to the difficulty levels of the user. For example, beginner, intermediate, advanced. So probably these two brigades can collaborate and work. Like whoever finishes first can contribute that work to the other brigade. And already myself and Alexis, we both are part of that brigade as well. So we'll try and see like what best we can do between these two brigades to make it work. That is for first release. The idea is to take up the quick start available in the wiki and then convert it into a GitBook, and then just get the feedback and see how we are doing. So this is how it looks like. GitBook looks like a cloud service wherein we can actually link our GitHub account and start creating books. And then it supports the GitHub flavored markdown, so you can just start writing a new chapter or aggregate a new chapter wherein the the content remain in your GitHub account, and then the view will be rendered here, and then probably there are options to actually export it into PDF or other file formats. And maybe to start with, you can use your own GitHub account and try creating a page, and if things look well, then probably we'll have a common documentation user account in GitHub, and then we can start maintaining that.
Sure. So this explicitly needs to be, this is explicitly a cloud service by GitHub that's free.
Yeah, I mean, they also offer private stuff, but then for public it's free.
Okay, and so it needs to just, well, theoretically, you could link to any Git source control, or does it have to be GitHub?
I think they are also okay to carry with Dropbox and all that stuff.
Okay.
It's from what I can tell, it's basically a way to structure your Markdown or Markdown or other formats, and then generate a bunch of more complicated metadata and generate a fancier format at the end. So if you know Markdown and you add their small amounts of metadata and organize it in their way, you get good output at the end.
Mm-hmm.
So Zach, would this then collate the markdown that we have in Core, for example?
It could be used to do that. It's just a matter of getting things in the right structure. Let me I can find the documentation. Their documentation page was quite good about how things are supposed to be ordered.
Because we just still do kind of inline documentation in each of the repos or modules, and this would aggregate that into a structure.
Yeah, that's my understanding. I found it.
Should we make you the presenter?
If you have the chat there, you can just load it. It's a link.
Oh, yeah.
So you have a metadata file in JSON format, and then the rest is just Markdown.
Yeah.
Organized by file system structure.
That's similar to how a book looks. Yeah. Interesting.
So basically, the GitBook service is basically a WYSIWYG Markdown editor that's backed by the Git repo.
Yeah. And they don't have this full-fledged standalone editor as well.
How are like merge conflicts and stuff handled? I mean, Git historically is not great at dealing with concurrent editing for English.
Since it's version, right? So it's just as good as your readme.md.
Right, which is, you know, if you have a lot of concurrent editors on file, it's not great.
I mean, that is the same funda for Novel source code, right? So you're just treating the text files as source code. That's it.
Yeah. I mean, I get that. Do you know if it permits like real-time collaborative editing, or like via the cloud platform?
Yeah, that's it. They put a quite covered. So I think so. It does.
Cool. Well, the thing is, right, it says like 5 collaborators. What does that mean? Does that mean a project, a GitBook project, can only have up to 5 user accounts?
A free GitBook project.
Right.
I guess there's 2 options here. One is using it as the format, and one is using their customized editor. Using the format seems reasonable. Maybe using their editor does not. And if we do need the real-time collaborative editing and that sort of stuff, then that might be a question. I personally I would rather have documentation, at least technical documentation, be with the code in the repo rather than have it be somewhere else, like in a wiki, and then you end up with issues of wiki versioning, and it just quickly goes downhill because when you try to use something that's intended to be versioned along with code, and it has a separate versioning scheme, or it has no versioning scheme, then you end up quickly having trouble.
Yeah, no, I completely agree. And then if what you get generated from your documentation is like a web page or something, having like a local web server that runs that documentation for the branch that you're currently checked out in works pretty well.
Yeah, we can even link it to the UI.
Yeah, exactly. No, I think there's definitely some agreement here about what you're saying, Zach. The reason I just have, I'm asking the question is because, sometimes the people who want to get involved with documentation writing are the people who are writing the source code, and sometimes people who are writing documentation are, maybe less technical. And the question is, is the barrier to entry for, the less technical folks who want to write documentation sufficiently low that they can do that?
So, how low of a barrier to entry do you want? I mean, if you have people who are coming in and they do you want to require that they know how to use Git, or do you want to have it be something even lower than that? That kind of is the with any of these tools that have a back end that is a version control system. Do you want them to understand that version control system before they can start contributing or not?
Well, so I mean, from my personal perspective, I don't think requiring someone to sort of know Git is too big of a barrier, but I know that there are people in conversations that I've had specifically around ONOS documentation who believe that understanding a version control system could be a sufficient barrier to entry, especially for folks that are going to be writing sort of the documentation for getting started type stuff.
Completely agree, because the documentation people I've worked with in the past, I think, haven't used it and what is the barrier.
I think we are not trying to do away with the wiki there. Wiki is definitely going to stay there, but we're just trying to make things organized with respect to the release, right? And people who are managing release, they will have to know Git.
So the people who are managing the release, you're going to have to know Git. And the developers who are going to write some documentation alongside the code that they write are also going to know Git. Yeah. But for people that are going to be writing sort of like the getting started with ONOS or the here's how you can spin up a cluster, or here, people from a user perspective more, or like a, the high level type documentation, that type of stuff. Those folks may not understand what version control is or how to deal with it.
Right. So the quick start is just, this GitBook is not intended to convert the quick start information from wiki to GitBook, but we're just taking this just to trial GitBook. So that's not the intent of GitBook, if I understand correctly.
So there's sort of a split between the intro documentation and things that, like, for example, getting started with ONOS probably hasn't changed a whole lot over many versions, whereas the internals may have, or the specific documentation have. So it's almost like you want to split between the things like the getting started that could remain in the wiki and the other more code level stuff that maybe should live with the code. And I'm not sure if that's a good split. We're discussing the same thing in Cord, so.
I think it's really a matter of consistency of format, right? Because are we distinguishing between types of documentation and what they'll look like? I guess if we PDF it, it doesn't matter. I'm just trying to figure out if there is a delineation.
Well, so for example, there's a pretty cool real-time collaborative LaTeX editor, which is Git-backed, called Overleaf. And I was sort of thinking that GitBook might sort of be something similar. But the idea with this is that you create a new paper, you have a sort of a kind of WYSIWYG-based editor, or you can go into source if you want for your tech stuff, and then you get the PDF version of your paper. And if you have multiple people that are on the same link at the same time, you it's not quite as good as Google Docs, but you have sort of the Google Docs like experience. And then what happens is periodically it checkpoints automatically. You could also have explicit saving required, but with collaborative editing type stuff, sometimes the edits come together. Anyway, these checkpoints are backed by Git, and so if you go into sign in and create an account, whatever, the labels here are just Git tags, basically, and then you can also get access to the Git repo if you want. And so I think this is sort of an example where you have something that's backed by Git, so it's something that coders could theoretically work with. The workflow of doing editing via Git and via Overleaf is not great because collaborative editing could stump on new stuff that's coming in. But yeah, I mean, I don't know whether if you had so yeah, I haven't seen a tool that would work well in the context of sort of hiding version control for people that didn't want to deal with it, and also make it available so that people who do know version control could check documentation in the process for reviewing that documentation could be done. Because the other thing about something like Overleaf is that there's not a review that happens. Like every change is, like every author that has a link is assumed to be equal collaborator. And so anybody can type whatever they want in, and it's not like code goes through, the documentation goes through a review, or the new content goes through review. It's more like a Google Doc where anybody who has access can add. What we kind of probably want is something more along the lines of Google Doc and comment mode, where you can propose edits, and then those edits have to be accepted. Kind of like that's the code review process. But if it was easy to kind of say, here's my changes, and then when you click save or whatever, it goes through the same sort of code review process that any of the source code would, maybe that's sort of the type of tool we want to strive for. But at that point, then they have to understand enough about the code review tools that do like merges and conflict resolution potentially. At that point, you know, maybe you just kind of give them a GUI Git client and call it a day.
So it sounds like we have both a tool problem and a human interaction problem here. One being we want people who don't have a sort of have that sort of version control mindset to be able to contribute, but we also want to allow people who do have it to be able to contribute and to be able to manage it with all the richness that you can have with that version control. Another option might be to have people use, say, Google Docs or some other thing, and then just have a process where when you near release, there's a review process that gets it into the Git repo or gets it into the wiki. Or it sounds like we need to work on our human process and see how many times we want to touch things. And how we want those reviews to happen, as much as we need to talk about what kind of tools we use.
Yeah, I mean, I think before we discovered Overleaf, like a long time ago, I wrote a tool that kind of did that for text editing, which took Google Doc as the source, downloaded the Google Doc, and then auto like periodically generated the text that was available via URL. But the question then is like, okay, the Google Doc is the authoritative source in this case, and like checking the authoritative source like from Google Doc into Git. I mean, that can be done periodically, but then the question is, how do you sync changes back? How do you resolve like conflicts if and when they do arise? And how do you do review of those changes that are coming in? I mean, you could try to build something like Google Doc that like periodically, or you know, whenever there's a Git change that gets checked in, it updates the Google Doc automatically. Like it forces a change, and then periodically polls the Google Doc for new changes and like pushes them as reviews. But the question then is, as people are reviewing the doc, then you know, what is the skill set required for people reviewing documentation? And it should probably be similar to the skill set of the people who are writing.
It sounds like we're trying to do a lot of work to get a bidirectional workflow between the two tools, and it's the entire benefit of it is to benefit a subset of people who don't want to use version control tools. And I'm wondering if that's a. I mean, I don't want to exclude people, but I'm wondering if that's the right optimization.
What we need to do is identify the sets of people and then figure out the tool sets for each of them, right?
I mean, if it's a training problem, we could maybe that's the thing we need to do, is to focus on getting people further up along, maybe a training and a local tooling problem versus providing them an online tool and then dealing with this synchronization issue, which I don't think is easily solvable, as you've described.
I agree that we probably want to use standard tool sets and not build our own. But I don't know if that means distinguishing the users and then identifying the different tools for each of them. I don't know if the training will right, that barrier of entry can be addressed by training. Part of it is just some level of discomfort, I assume.
Well, I mean, I think, you know, having to like, you know, run an editor locally to do your edits, and then like run a web server locally to look at your edits, and then do a git commit and a push and a review, like that all kind of sounds a little bit complicated to someone who's less technical. But the question is, like, for the types of documentation that we're talking about, which is build and release process, okay, those people are going to be technical and understand version control. Corresponding user network admin documentation. I mean, those types of people could be people that sort of view the code and apps as more of a black box, and maybe less familiar with sort of software development and version control. And then the developer SDK documentation, I mean, that's probably more or less going to be written by people that are low enough in the code to be reading it. And so I think there's probably just the sort of user network admin documentation that could be really a challenge. Maintenance of the build, test, runtime toolkits, CI process, release process. Yeah, I don't know. I mean, with any of these things, right, like, once you sort of know how to use the version control systems, and like, it just seems like, oh, it's just easy, just do it that way. But I don't know, trying to put yourself in the shoes of someone who doesn't understand digital chain, and like, I just want to make this one edit, and you're telling me I have to like make an SSH key and register it with Garrett and download Git and learn what committing is and stashing changes, and you know, I don't know. I could see how it kind of adds up, and someone who's just trying to, like, you know, fix a typo or, you know, add a line about a missing step could just say, like, forget it.
If that's if those really minor changes get pushed in maybe we should figure out a better way to deal with those. Like maybe there should be a if you have a very minor change and you don't want to go through the process of manually doing it yourself, you report it somewhere and someone fixes it. Like, and maybe that goes in the ticket system, or maybe into Slack somewhere, or something like that, where somebody else manually makes the change, but it's an easy way for somebody to suggest the change. And if you're going to go into full document editing mode, you need to you would need to go through all the steps of getting a development environment, or at least get the code downloaded and through Garrett and the rest of it. I mean, that is sort of a make it our problem if somebody wants to make a little edit, but it still gets those edits in.
They are into completely into the coursework mode. So they are into publishing coursework and stuff like that. So Alexis, so what's the latest news in Teaching Brigade?
In the Teaching Brigade, actually, we haven't started yet. We are expected to start in at the end of May, but I guess we will be using the one shot previously, the GitBook, but it's not confirmed yet. So I cannot answer this question very precisely.
All right. Okay.
Yeah.
So the other question, the targets for GitBook, is it just like PDF, or is it like a live HTML page, or?
So they have the web view as well. If you go to the Explore there, you could see some free books out there, and then you just start reading it. So read, or you can download as a PDF.
Okay, so what should
Read is just open in this fashion, so that
okay, you get an outline on the left. I mean, for a lot of this type of like technical documentation, I mean, is the book format like kind of what we want, or is it? I mean, is there?
So it opens with this, right, where there is some markdown documentation, gets reflected on the wiki. That was kind of a nice, quick way to get the version document without necessarily a huge amount of structure.
You open vSwitch community?
OpenSwitch.
The HP is one?
Yes.
Yeah, we were talking about
I
this.
see that you're wearing one of the shirts.
Yeah.
Well, this is so like the GitHub wikis, right, are Git-backed wikis, and so this is the documentation you're talking about.
Yeah.
Yeah. So this is just the GitHub wiki, which is Git-backed. So you can check in code and stuff there, but it's a different repo.
I think she's talking about this one. I think they stopped this and then they moved to a GitHub mode. So this was their original documentation, and then now they are moving to GitHub.
So with the GitHub wikis, yeah, they're separate repos technically from the source, but you can either like clone the wikis and like make edits and commit and push and stuff, which is like kind of what you need to do if you want to add images. But if you're just like a user who sees an error and wants to make a change, you can like click on it, edit in line, like with the online WYSIWYG editor, and then when you click like save, it basically builds like a pull request automatically on your behalf. You can put in some comments about what you changed, and then like it shows up as a pull request, and then other people can see the wiki pull request, or depending upon like whether you can commit directly or whether you don't have commit rights. Other people could see the pull request, or it gets merged in directly. There could be comments. I don't know.
Ties us to using GitHub, though, doesn't it?
Sorry?
Doesn't that tie us to using GitHub's wiki
Yeah,
display?
that would tie you to GitHub.
Yeah. It looks like there's a tool for taking GitBook and running it through Pandoc, which will basically put out whatever format we'd want. But in the general scheme of, is this the right format for the kind of documentation we're doing? I think that's still up for discussion.
Probably, as Brent suggested, right, we could just choose wiki for this one, user and documentation. So that can be more open in web-based format. And then for build, release, and developer SDK, we could have closed version of GitBook.
I guess for the user documentation, I mean, there are some things that change from version to version. Like, for example, if we add support for, some kind of deployment mode or mechanism for doing deployments or whatever, that could possibly change. And if it's in the wiki, we still have this like versioning problem and like staleness problem that inevitably will occur. Like the further you get from like the source of truth, the code, the harder it is to maintain like cohesion between the documentation and the code. Like even comments in code sometimes get stale. That's like as close as you can go, basically. But I think I agree with Zach's original premise that the closer we can put the documentation to the code so that like they can be checked in and reviewed together, like the more likelihood we have of having higher quality documentation that applies to a specific version of the product.
In fact, this is again one of the line items, the wiki documentation.
just wanted the starting point to move to Markdown. And I mean, Simon is starting to do that.
Okay.
So are all the modules moving to that, or is Simon different? Is there some plan thought behind it?
I think Simon was just trying something new out. I don't know. I vaguely remember him saying something about it, and then he was to report back about how that was going, and whether this process made sense, and whether it should be applied to larger projects.
He has to commit.
I understand, but like it wasn't part of like a larger process. I think that was Simon just wanted to try something and learn from it. I guess we'll see.
Because in general, on the core side, the Markdown documentation has been pretty good and at least kept up to date with each of the releases.
So they, I mean, how the documents are getting served? Like they have a web server wherein they exist. So Zach, you have any idea like how the documentation in code is getting cooked up?
Could you repeat the question? I didn't quite hear it.
No, it's like in code. So how the documentation is getting cooked up? Like you guys also use Wiki to capture information for all the releases. Like you have these matches.
Yeah, and we're having the same discussion in parallel. So we have a wiki, and we have issues with it, the freshness of information on it. Well, we've kind of, I think one of the ideas, and Ian can comment on this as well, that we're thinking of having high-level sort of design-level things live in the wiki after we review them and go over them in Google Docs, and then having the technical level stuff or basic README sort of gets in the actual code repos and get pointed to by the wiki. Disconnect there where the you might want to have in the wiki, you might want to have getting started documentation. So things might occur in two places.
So yeah, I think both are using just Confluence, different versions of it. So that's why I look a little bit different. Plus the skinning is slightly different. I actually am not sure exactly what the backing store for Confluence-based wiki is. I think it might just be a database, like a relational database, or I don't know if they have like some other file format thing. But yeah, it's not Git or anything, I don't think.
I was thinking like if you could just feed in the Markdown, the Markdown gets checked in into GitHub, then it renders using the wiki. It will be like best of both worlds.
Which is kind of what OpenSpace did initially, right? Because it was Markdown files and then it was rendered on those OpenSpace websites.
And then they move now to GitHub.
Yeah, but that's because part of it is they changed the people properties too, right?
Yeah, possibly.
Because it went from an HP project to
Dev, yeah.
Yeah, so it looks like there's most of the data for the Confluence-based wiki, they're stored in the database, and then attachments to the wiki pages get stored in the.
Okay, so what are we agreeing here? So are we going with wiki or GitBook?
Well, so as far as I can tell, it's probably worth trying to determine specifically the types of individuals or types of groups that are going to be contributing documentation and what their skill set is. Because, yeah, I mean, if we determine that their skill set is they all have Git experience, then we can use a markdown-based solution without a problem, and they'll be able to commit and review. If we determine that their skill set is not has nothing to do with version control, but they're willing to learn it, then maybe we find some tooling that makes that process as easy as possible for them, but still go with a sort of Git first approach. And then if their skill set is no version control, and we determine, or they determine that the barrier to entry, so to speak, is too high, then we'll need to potentially pursue a solution that either permits the Git-based and non-Git-based synchronized environment workflow, or say that all the documentation has to go through a common process, which is not strictly dependent on version control.
So can we maybe have an action item that pings or polls a teaching brigade?
Or do you think that we could run some kind of survey and then ask, float some emails?
Or just in a meeting on the teaching brigade side discuss,
Okay.
right, whether this is viable or not.
Okay. Fine, okay.
Because, yeah, I mean, I think if we do determine that all the people that are interpreting documentation have familiarity with version control, then putting the documentation source as close to the code source has a lot of nice properties. Zach Allen.
Sure. Then let's ask teaching brigade to collect that feedback and then pass on to it.
Or the other option is, right, we use the content of the markdowns to build the architecture and internal documents. Because we kind of need to refresh that, and maybe it's a targeted thing where it's fully technical.
So you're saying that maybe there's different sources, different storage and skill sets required for different types of documentation.
Yeah.
Technical docs live in the code, and then there's some people that act as a bridge between the technical docs and the more user-facing docs, which live somewhere else.
And what they can do is they can use the technical docs to provide that abstraction, right?
Yeah. There's a Google Drive connector for Confluence. So similarly, they have some GitHub connector. Yeah, we have. Everybody has markdown documentation as source code. Okay. Just like I think you have to pay for it.
Do you pay for it?
I think you have trial. You have community.
Community license for both coordinates almost.
Yeah, so try if you could get this one. That will solve. This will solve the markdown can still reside in GitHub, but it can be rendered in Wiki.
And then how do you version the wiki?
Wiki is already a version, right?
Well, so the wiki, how do you couple the wiki version to the release version? And the problem that we've had is that the wiki's grown so big that when you try to run the
So maybe this will help take care of it, so it reduces the content that is actually on the wiki?
Yeah.
But, yeah, one challenge, we used to have like the archive spaces for the different ONOS releases. So like there's a space, if you look in archive spaces, there's one, you note that ends at 1.5, because after 1.5, the plugin that builds the clones of these spaces just crashes. I don't know for what reason. We never really looked into it and totally forgot about it until about now. But yeah, we used to version the spaces by creating clones of them at the time. But the challenge we always had was, in addition to the fact that there's a technical glitch that the spaces couldn't actually be cloned, that's why I think we worked through. But we'd get to the release, and we release the source code, and then we say, guys, go through and edit, update. You have 2 weeks, update the documentation. It just never got done. Like the documentation never got added or updated, and it got to the point where it's like, oh, we're at the next release, and now it's like, are we ready to snapshot the space? And it's like, oh wait, no, I haven't updated my stuff yet. And it's like, so getting people. So I mean, my feeling is that if it doesn't gate the check-in process, like if you allow check-ins, you know, and you don't have test gate them or check style gate them or documentation or whatever gate the check-in process, it's not going to get done. And expecting that there's someone that can spend, you know, large amounts of time to like go through and fix all this stuff is kind of unrealistic because, you know, funneling the work of it doesn't scale. A large group of people generate lots of work is not going to like consolidate nicely for someone. So ultimately, we have to find ways to like push things like writing tests and documentation and code style and everything like as close to the gating process and check-in process as possible, so that it just gets done. And you know, it's like you add this big module. It's like, well, where's the documentation? You know, that's part of the review. Maybe even an automated step where the build fails because, you know, I don't know, whatever. Or a viewer says, yeah, there's no documentation here, right? And okay, now the person, you know, has the context. They just wrote the code. You know, they're in sort of the best position to write the docs, or at least, you know, start the docs, put a skeleton there, put some bullets, which could be fleshed out at a later date. But you know, start somewhere, and then you know they're also motivated because they want to get their code checked in. Whereas later, getting them to be like, hey, can you go back and write documentation on that module a month ago? Because now we're trying to do the release. It's like, no, I'm busy. It's just not gonna get done.
One other thing that could be helpful on this is that we've implemented in Cord is we have some tools that auto format not our documentation, but some of our other specifically Ansible scripts that do just sanity checking. It might be helpful to have like if everything's marked down and we specify that you have to use the MD extension, and then we run it through, they do have markdown lint tools that can do things like make sure you don't have really long lines and those sorts of things, which are helpful for enforcing a sort of a documentation standard that allows for easier refactoring. And that might be something to consider doing if we're going to force all documentation through a gate. It is a pain in the butt for when your code, your documentation fails your code check-in because you have 81 characters instead of 80, but in the long run, it generally is helpful.
Okay. So what is that gate setting? Again, same question.
Whatever it is, we have to build documentation for the building infrastructure team.
One action item on our event gave was to reach out to the teaching brigade and then get the list of, get a category of users who will be accessing the documentation, who will be contributing the documentation. And depending upon their skill set, we may try to see, can we assume that the Git skills are like prerequisite, or like you need to do some stuff. And can you guys check this from your end? Can you guys check this from your end?
Yeah.
So this will be our item 2 to check. And item 3 probably will have mix of both wiki and GitBook. And then we'll definitely have the headache of tying wiki with the version control. But then we'll have to see how best we will work on it.
GitHub gist macro?
Not just GitHub macros for complaints. This I think you can edit using Markdown, but it will save in complaints only. You don't have GitBook.
Yeah, this is I'm gonna be back from the appropriate way. Okay, so sorry, the second action item was to figure out if we can add a plugin for Confluence to render Git back Markdown.
Yep.
And the third thing was to
Have both GitBook and Wiki.
and Wiki back together.
We discussed this, right? So that the build and release documentation and the developer SDK go through the Git cycle, as the user documentation will have it.
Render. Okay, render.
Yeah. And then we can stitch these three things together using the process that you highlighted. Probably we'll mandate that as part of check-in first.
Okay. Yeah. I'm gonna put these notes somewhere else, but I copied them to this document, I guess. But fair enough. Okay. So yeah, I mean, unfortunately, I don't think we're sort of in a position yet to mandate or to make a concrete suggestion, but I think we have reasonable steps.
Yeah, nothing question on the version of it.
Yeah, you basically don't.
I know there's no answer, but that's one of the questions that make it usable.
Yeah.
Assuming you we fix this plugin issue, why don't we mention this?
Well, the thing is, you need to actually convince people to go into the wiki and update documentation when they write source code, right?
That's what we are doing as part of the process, right? We are actually mandating that to be part of check-in.
Yeah, but the thing is, so what would you do? Like as part of check-in, you'd have to put like a link to the new documentation in your check-in message or something?
Yeah, it will be tracking Jira ticket. Jira ticket, we are tracking the source code check-in.
So
We'll be having a unit test.
Markdown? Change it to Markdown with their component? Is that what we're
They'll have to create a wiki page, and then they'll have to provide a link to Jira ticket. So Jira ticket will have entry to your source code. Then we have this get it plugin there, and then we have this wiki document link. And then if you're maintaining any other tool for writing unit tests, then probably you can link that as well. So when a change set is coming to a reviewer, he will have access to both access to the code, the wiki page that the author has created, and also the list of test cases that he has written.
So, but the problem there is that let's say you come along and you decide you're going to, implement some new feature or whatever, change the way ONOS starts. I don't know. Now, you have to go and edit the wiki to talk about the new ways that you have to invoke ONOS startup and make those changes before the changes are actually going to be accepted.
Probably their personal space, right? Just like how we have.
No, but personal spaces is like my own private, areas, my own private little mini wikis, right?
Yeah, so you just create your wiki and then you give me access to me. And then if I find it good, I will, something like a pull request, right? Well, I'll just transfer that page from your personal wiki to the main wiki.
Right, but I mean, okay, that's fine for new pages, perhaps, although there's a bit of a manual process, but for,
Existing pages.
existing features and stuff, now you've got to have someone do the manual merge and different stuff.
So don't we have the kind of staging page in wiki? There's something like accept, approve.
I'm not sure.
But in Git it will go.
Yeah, in Git, it goes in, and the source change goes in. Under the branches it goes into.
But then people need Git things. Something like chicken needs for it. Why don't we assume that people should have Git skills?
Well, so, we're kind of going in circles here, so.
We haven't actually done a poll for that, so let's not assume that. I think worst case is if they don't, the assumption is maybe we do it based on the type of documentation.
Okay.
So maybe still use the tools we're exploring, but set it based upon the user base.
Okay.
Or the documentation type.
Let's face it that.
Otherwise, I think we're not going to be able to solve this problem.
Yeah.
All right, so we have a good discussion regarding GitBook. So probably we'll take a break and then come by 4:30. Yeah.
So Josh is in Arizona, which is, I think, the same time zone as us right now.
Yeah, I think.
Sorry, Zach, sorry, is in Arizona.
Alexis, yeah.
Just call me Josh, right?
Sorry?
You can call me Josh right there, right?
Yeah, I did. Sorry about that.
Okay. I have to tell you this. This is totally off topic, but when anyone calls me a different name, 90% of the time it's Josh. I have no idea why, but the universe has conspired to call me Josh. So okay, just.
I can't tell you why that name popped into my head.
It's so strange. So okay.
Name to Josh.
Yeah, I don't know. Alrighty, sorry about that.
You can add it in your ID.
Well, I mean, I think what we have left to do today, right, is to go over, by build and package infrastructure, I think it's more or less just the package infrastructure, because I think we kind of hit the build stuff to death. So I can go over, well, we already talked about sort of the anatomy of the OAR, but we can revisit that and talk about the overall ONOS package, which we also briefly touched on. And we could do that if you want, and then take a break. And I'm not sure what objective and scope, is, what sort of more discussion you wanted to have on that today.
I mean, I was thinking to go over this item. What is this Brigade supposed to do? Stuff like that. But I think we're good, so probably we'll just wrap up with the packaging stuff.
Okay. Yeah, I can talk through that, and then maybe we can adjourn for the day. I'll take the control back here, and then sort of walk through the anatomy of the packages, and maybe not explain too much about how they're built per se, but just kind of talk about the components.
One thing that triggered a question I had around the charter was that when we were talking about how do you ensure that the people committing code have unit data for documentation, is that something that the team is trying to build as packages and tool sets around? Is that within the scope of the charter, or I wasn't sure because Brian mentioned it?
Like when you submit a code into a code carriage, right? So someone has to approve that. The person who is going to approve it, he should be cautious enough saying, okay, what is the code is being worth checking, and what is the test case that is being covered as part of this particular code changes. So it is existing or new. So until that the person is not satisfied with the test coverage, he is not supposed to give plus 2.
So we're saying guidelines to
That's
the
what, yeah.
reviewer.
I mean, that happens in my org. Like, if no UT, unit testing, absolutely no approval whatsoever. However, the code changes are. Okay. I'm just saying. So, I mean, that's why you can enforce, like, okay, otherwise, like, you cannot, like, I mean, say, compromising the quality of code that you have been checking. See, normally when we keep on going, so we keep on having some unit test cases, maybe manual or automated. But at least one sort of UT has to be done. Otherwise, you can't maintain that consistency in the code. I mean, little seems to be a little bit harsh. Disagree, but.
But I think her question was whether it is the responsibility of this team to enforce that.
Because this team, I don't think it's. I think it's not this team's responsibility.
That's right. It should be done. That decision should be taken in some kind of CSG or something.
We can put some sort of rule or some sort of flag saying, okay, you don't do it.
Brian mentioned the gating, so I don't know to what extent the gating was meant.
He just told whatever top of his mind that this is how a normal government should be. Isn't it?
Minus R1. Anyway, yeah, I took over percent rights, but anyway, I'll walk through this maybe more slowly. So, so when we create the ONOS tarball, what I did is I just extracted that so that we could explore it. But high level gets pulled into a directory with a version number next to it. When you start looking at it, there's this version file, which is just the version number. This is also the version that got more or less baked into the artifacts along the way. There's this bin directory, which has some scripts. The ONOS script, which is the client, ONOS secure SSH, which rewrites or deletes the oh, great, whatever. So this one basically just adds,
with the host, right?
which adds the user to the host file, yeah, the craft host file, and then the key of the ONOS cluster. ONOS service is for starting ONOS service. JP enables to enable profiling for the cluster. Form cluster creates the cluster metadata file from the environment variables. Anyway, so there's some binary files that are useful to people who are trying to start ONOS. There's also this apps directory where the OAR files get deployed. This is where ONOS looks on startup to preload the application. There's also the carafe distribution. And so this is basically regular carafe with some of the config files in it updated to load the ONOS features. So for example, etc org Apache carafe features config. We have the standard boot features, ONOS API, core incubator, CLI, etc., as well as adding the feature repository for ONOS as well. So for some core components, they get loaded automatically on startup. Others get added by the application subsystem. So there's also in system, we package ONOS project. So we package all of the sort of artifacts for ONOS core, API, etc., as well as like drivers, providers, stuff like that. So those artifacts, those jar bundles get preloaded into the graph environment so that graph doesn't have to fetch them from Maven Central. What else? So if we go back up, so the ONOS package, yeah, was graph, apps, binary files, and then init is, this is the stuff that would go into the system 5 configuration, upstart, and systemd. If you wanted to run ONOS as a service on your machine, on your Linux machine.
So if you install a feature in cluster 1, node 1 of cluster, then how it gets actually replicated from node 2 of cluster?
Yeah, so by default, when you like spin up an ONOS instance, everyone will get this same tarball, extract the tarball, and start it. So it's a symmetric deployment from a core feature perspective, because they all share the same feature config. Now, if you go into the config file on each individual machine, or you decide to like go at the command, the graph CLI, and start typing feature install or feature uninstall, then you're on your own. Like you're effectively, there's no synchronization at the bundle or feature level across clusters beyond the fact that they started with the same configuration. But for applications, when an application gets loaded, and this is the way we deployed new drivers, new service applications, and new protocols and providers. For applications, the application system takes in the application OER file, distributes it across the cluster, and then manages the state of that application across the cluster. And so the application subsystem, through a consistent store, will manage making sure each of the nodes in the cluster is running the same features if you go through that way. So yeah, so that's basically the overall ONOS package that gets distributed both in tar format and in zip format. There's also sort of the anatomy of the apps that I alluded to earlier. So if we take a simple app like the forwarding app, we can see that in this case, we extract the app XML file. And the reason we do that is just so that it doesn't have to look into the OER to do that. But yeah, basically the app XML file is just a metadata file which describes some metadata about the app. App's name, company of origin, version, title, category, the features repo, where there's going to be another features XML file, the features in that repo that this app is comprised of, and then the app dependencies. And then it also has a long form description because you can't necessarily have like all sorts of crazy characters in the parameters. And then this is also a list of the artifacts that are contained, the bundles effectively.
Even in Bugs version, this app.xml and feature.xml do come with?
Yeah, they're just auto-generated.
Okay.
Yeah, so in the Maven version, there was a way to generate simple ones, but if you wanted to do things more complicated, you had to write your own. In Buck, we basically have the features that you want to include as parameters to the rule, and then we generate the files for you. So if we crack open, for example, this tarball, you'll see that there's really 3 files. One is the app XML file, which I said we just extract here to save like one operation. But the app OER would also contain the same copy. Then there's also the, this is the standard Maven style location for a particular artifact. And so there's a features XML file, which basically refers to one jar file, and then there's the OSGi compatible jar file. And so if we kind of keep turtling our way down, we'll see there's the M2 org blah, blah, blah. So down here we have ONOS -features. So you have, this is the, let's open these side by side. features and so in the bottom we have the app XML. This describes, refers to one feature, which is org ONOS project, ONOS apps forward, 1.0 XML features. So that's effectively mapped to this file in the top. This file in the top has one feature called ONOS apps forward, which is the feature that we told about before. And then it says that there's one bundle that needs to, or there's another feature, ONOS API, that it depends on, and there's one bundle that this feature brings. So this bundle is the jar file we were looking at before. All right, so the last one in this is the jar file itself, which has a manifest, which is OSGi compatible. And then it's got the shell config for CLI commands. It's got the reactive forwarding XML. This is the system component runtime registry, whatever, SCR, Felix SCR, component descriptor XML. And then we've got the various classes. So just for completeness, we'll just extract this. So the inf manifest. So you can see there's, in this case, we're exporting org ONOS project forward, that package, at version 1.10.0 snapshot. And then this uses a bunch of stuff. Yeah, there's only one package here, and it uses a bunch of other stuff. And then we import Guava version 19 to 20, between 19 and 20. The Apache shell package for the commands, ON.Lab util, ONOS project config, ONOS CLI, ONOS project netflow criteria. So there's all these packages that get imported, and OSGi will manage building a class path that makes all of this work together. So yeah, I guess, so we started at the high level, work down, starting at the low level and working up. You have these OSGi jar targets that comprise like a single module, one or more components. Then you get this OSGi ready jar. We create a features file that describes that jar so that the bundle can be loaded by OSGi or Carafe specifically. Those get wrapped into OAR files, which also includes some application-specific metadata. Thomas has a patch now, which allows you to have like a single bundle app as just an OSGi jar. But for now, yeah, there are these OSGi jars, which are have the structure of the Maven repo to place items in. And then we take all the built-in applications that we're going to put and all the regular system components and system level features and bundles, package those into a tarball along with Carafe that gets distributed as the ONOS package.
So the path, so when that path is getting
it may already be. We just may not have the code to generate the jars with the metadata. I'm not sure. We can check with them on that. But yeah, so apps can be single bundle, single feature, like this one. They can be single feature, so one feature grouping, multi-bundle, so multiple bundles together. They can be multi-feature, multi-bundle, where you have like an API feature and an implementation feature with an implementation bundle, an API bundle. There's different reasons for structuring it in different ways, but I would say the vast majority of apps are single bundle, single feature apps that just get loaded. So having the OAR wrapper around it is just kind of one extra layer, but potentially confusion, which may be avoidable. Yeah, that's more. Any questions, or you want me to dive into any more around that? It might have been too quick.
page for it again. The flow was good. Zach, Alexis, any questions from your side?
No questions so far.
Yes, maybe.
Tabulate there.
Yeah.
All right. Well, let me give you back the controller. So.
I think we are done for the day. So probably Alexis, like, you just drop off and go to bed.
All right. Thank you, guys, and see you tomorrow. Bye-bye.
Bye-bye.
Great. Yeah. So tomorrow, I guess we'll do the pipeline deep dive, bug deep dive, discussion of code disaggregation and repo tool, and depending upon if we have time, maybe a deep dive into the ONOS Warden STC.
Yeah.
We can either do that tomorrow or if we have some time.
Yeah. Wednesday we have after 3 it's like free only. After 4, so
Yeah.
you will take that slot.
You know, we also have a TSP meeting from 4 to 5 on Wednesday.
Okay. You can attend live.
Yeah, you can attend live, exactly. Attend live. Cool.
All right. Thanks, Zach. So meet you tomorrow.
Yeah, I'll be on tomorrow.
Okay.
Yeah. Okay. Thank you. Bye-bye.
Bye.
All right. Thanks. Bye.